What's the fastest path to get out of software engineering and into the data science field, the data and analytics field? Well, it's not what most people think. A lot of people think I'm going to go straight into data science, and that's not the right way to go from a software engineer's perspective. Why? There's just too much that you don't do on a regular basis to learn. So that's going to be a whole bunch of, it's a time sink, and going through courses to learn data science is probably the hardest way for you to make the transition. So I want you to target a different role. And it's not the machine learning engineering role either. It's the data engineering role. This has a higher rate of growth than data scientists and machine learning engineers. It gets paid very well. Typically, you're going to get a significant increase from a software developer's salary. As you progress up the ladder from mid-level to the senior plus plus, salaries grow very quickly. So it's a great track in, and you can transition from a data engineer to other roles like machine learning engineer and data scientist. So let's talk about what skills you need to have. First, take an inventory. This is going to be critical for you. Look at the capabilities you already have, because if you have something like the Java-Python combination, most data engineering jobs are looking for Java and Python. C and C++ are big as well, but they typically are looking for two different programming languages, and one of them is a more traditional back-end software development, software engineering programming language like Java. Some even ask for Scala. You want to have a good focus on software engineering, software design, development, those best practices, some of the architectural capabilities, things that you use probably every day as a back-end software developer. Next, cloud. Amazon, Azure, Google Cloud Platform, all three of them are prevalent, so whichever one you're familiar with right now, you're probably in good shape. SQL and NoSQL, significant amounts of SQL knowledge. You'll stand out just because you have that background. And you've probably done a ton of this. You have experience with, like I said, the more rigorous side of software engineering and software development. So that is, if you're looking at what would I focus on in my resume, that's what you want to hit on, is the fact that you've deployed to production, you've built reliable systems, you can handle scale, all of those things that you're used to for software engineering. Highlight those, because they're benefits for data engineers as well. Now, the concepts you don't have, these are the ones that you're going to need to learn and acquire as quickly as possible. The main concept is what's called data ops, or data operations. This is the flip side. You do the software engineering, you do a whole lot of what you do now, you're going to do in data engineering, but you're also going to add on this data operations, this ability to manage an entire workflow and build out the tools necessary to support what happens downstream, which is the data science and eventually the ML engineering. The main concept is data curation. This is purpose building data sets for analysis, visualization, and data science further downstream. So you don't have to understand data science or machine learning or analytics or any of that. You just have to understand the basics of curating data sets for the purposes of those activities that are going to happen downstream from you. So you'll be collaborating with data scientists, but you don't need to know all the math. And that's why I say this is the excellent transition for a software engineer trying to get into the data field, because during those interactions, you're going to learn more about machine learning engineering and about data science. And so if you want to pivot into one of those two roles later on, which would probably be a good career path for you, you're going to be working with that team. You're going to be working hands-on with them. You're going to pick up knowledge from them. And when it comes time to transition, you've already got an existing relationship into those teams and groups. So the transition is going to be much easier from an internal promotion standpoint than it would be trying to break in from the very beginning. So it's very, very important. Make sure you're working with downstream teams as part of this curation process. So this is purpose-built data. Your data gathering for the purpose. And this is really the big umbrella concept of what you're learning, is data ops and data curation. Now, everything engineering-wise has to do with the data pipeline. What is a data pipeline? It's just the automation, automating all of this data workflow or data life cycle. That starts with data ingestion. That's kind of step one. That all that is, and you've probably done this before, is moving data from a source, whether you're pulling that from an API, scraping it, pulling it from files, just any place, maybe even an external database, and then bringing it in, moving it to a landing point. And this is where some of the platform knowledge that you're going to need comes into play. You need to understand stuff like Snowflake, Amazon's S3, even Databricks, and your more traditional, outside of the data warehouse, data lake, all those buzzwords, you're really more traditional databases, your relational and NoSQL databases. Knowing those, MySQL, Mongo, Cassandra, Microsoft SQL, those are all still used, even though we have scale and high end and all that other stuff. The tools that we use are fairly traditional. Now, after ingestion, you get to this concept of security and governance with data ingress and egress. So data ingress is data coming from the outside into the organization. There's an element of data quality, but also you worry about bad data, toxic data, someone putting a virus, malware, Trojan into that. And as a data engineer, we don't talk about this a lot. Data engineers handle some of the security side, and they work with the cybersecurity InfoSec teams to make sure data governance follows your security best practices. So ingress, a lot of that just has to do with firewalls, data quality. That's some things that you do need to know. And then egress, data moving from inside of the organization outside of the network. And so you're dealing with really loss prevention. You don't want data to leave in an unauthorized manner. You don't want people walking out the door with data or sending it, whether intentionally or inadvertently. So again, this is cybersecurity 101, doing access control, making sure that the data sets themselves are labeled in such a way that you would know this is a secure and sensitive data set versus this is more of an open data set. So this is data governance. These very small things like security, access control, data labeling, that's part of the data engineering job. And that's one of those capability sets that makes you stand out from everyone else, because everybody else is so focused on the software development and software engineering, they forget about the data governance, the data security, the data quality sides of the role. So you can definitely stand out if you learn just a little bit more about that ingress egress piece. And then finally, you're talking about the data transformation, data modeling. This is stuff you're already probably really familiar with. There's a couple of new pieces that'll come into play, like I said, for that purpose-built, that curation, building data sets for people like me who are going to do data science and machine learning with them. And the first is labeling. Datas need labels in order for us downstream to do our jobs, and labeling is a painful process. It's going to be something that you'll be in charge of keeping track of. You may even be part of deciding how labeling happens and how it works. So this is a little bit of a crossover into the data science and machine learning world, but you don't need to understand data science. You just need to understand labeling quality. Who does the labeling? What is the purpose of the labeling? What classes need to be represented inside of those labels? How do you keep them consistent? There's almost an extension of data governance. And then the second piece of this is just metadata. This is data about the data. And this is, again, more of a data science sort of facing function. You probably don't get a whole lot of this when you're working as a software engineer, but metadata explains where you got the data, how you gathered the data, really anything that the data scientist needs to understand in order to utilize the data and to rely on the data. So there needs to be some metadata around what it is, how it was gathered, and so on. So you're going to be accountable for that piece too. When we talk about frameworks, Kubernetes and Dockers are huge. Anything to deal with distributed data at scale, managing streaming data, especially high throughput streaming data. So things like Spark, Presto, Hive, Impala, Hadoop's around. Yes, Hadoop still exists. Any data platform concept, data warehouse, data lake. So you're dealing with things like Snowflake, Glue, S3, Redshift, going through the Amazon suite, but everybody has their own sort of suite and stack where it's a Google Cloud or Azure. So look for the equivalents depending upon which one you want to go through. But if you're looking at the Amazon stack, it's, Glue S3, Redshift, EMR, and Kinesis. Yeah, Kinesis. And so you're looking for also monitoring and performance management tools and utilities. That's going to be another piece of it. Once everything's in place and automated, you want to make sure that it's still performing well, that there hasn't been some sort of defect failure. And that's from a data quality standpoint as well as a serving. Is it accessible? Is it available? Are there latency issues in serving it to the people who need it? How do you get those skills quickly? There's actually a ton of classes and coursework out there that's absolutely free. So if you want to go the free route, you can go to Google Cloud has a data engineering training. So does Azure. AWS does too. All three of them are very good. They're comprehensive videos, and they teach you how to use their tools. They'll teach you best practices. They'll give you even some use cases and some example implementations. Those are absolutely awesome. Kubernetes, if you go to the Kubernetes website, they have training on Kubernetes right there, so you can learn a pretty comprehensive training set. And then looking at companies like Databricks also has free online training that you can take advantage of. So what you want to do is go through the data ops main points, look at a technology stack, just one consistent technology stack, whether that's Azure, GCP, Amazon. Look for the most common tools, warehouses, and then learn through that stack. By learning the stack, you're also going to learn most of the data ops and data curation process, that workflow. You'll get an idea of the pipeline components that need to be created in order to facilitate this whole thing. And like I said, kind of that end point where you're talking about ETL and that you're already familiar with, that data modeling and data transformation piece. So you've got, I'd say, 1/5 already down, and from an engineering standpoint, 1/2 of it down. So that is how you quickly transform from a software engineer into the data science field using data engineer as your entry point.